Hello, this is OCR Further Statistics. We're in Discrete Random Variables 3 and the first video, introducing the geometric distribution. In this video, we'll look at identifying when the geometric distribution is appropriate. You've already met some discrete distributions. Here are two quite similar looking situations. One of them can be modelled using a distribution you already know about. The other is a new situation. Which is which? What is the same about the two situations? What is different? Pause the video for a moment while you think about this. OK, hopefully you spotted that the first situation could be modelled using the binomial distribution. You'd need to know that the probability of getting a 6 was the same each time, which can probably be safely assumed. The second one is an example of the geometric distribution. Let's compare the two. There are similarities, which can lead to mixing up the two, so take care. Both situations deal with success or failure, two options. Both situations have a constant probability p. In both situations, the repeated trials are assumed to be independent. The big difference between the two situations is that in A you have a fixed number of trials, whereas in B you don't. In A, the random variable is the number of sixes. In general, this is the number of successes. In B, the random variable is the number of rolls. In general, this is the number of trials. X is binomial, with two parameters, n and p. Y is geometric, with just one parameter, p. This is the key difference you need to keep in mind. With binomial, there is a fixed number of trials. With geometric, there isn't. This means that a binomial distribution has a finite number of possible outcomes, whereas a geometric distribution has an infinite number of possible outcomes, at least in theory. To get our heads around the geometric distribution, let's look at the beginning of a tree diagram. So for our first roll, we can either get a 6 or not a 6. If we get a 6, we don't roll again. We only roll again if we didn't get a 6. So the tree diagram continues like this and this. OK, we'll come back to calculating those probabilities in the next video. Let's keep focused on identifying the geometric distribution. Remember, there are two possible outcomes for each trial, success or failure. The probability of success is constant and the trials are independent. The random variable is the number of trials necessary for the first success. And remember, the number of trials includes the first success. Look at this situation. Would the geometric distribution be a suitable model here? Why? What assumptions are we making? Why might it not be appropriate? Pause the video for a moment while you think about it. OK, what are we modelling here? The random variable hasn't been defined, but it can only be the number of times we have to select a suite before getting a red. Let's make that clear. OK, well now we're clearly counting the number of trials until we get success. And there are clearly two outcomes, so it's looking good. But will the probability be constant? And will the trials be independent? We need to make some assumptions here. Are they good assumptions? Probably not. I think these trials wouldn't be independent. You'd root around in a different part of the bag, and so the probability wouldn't be constant. But you could overcome this. A simple way would be to shake the bag well between trials. You need to be aware of the conditions and assumptions when modelling the geometric distribution. They aren't difficult, but you do need to note them. That's the end of this video introducing the geometric distribution. The next video looks at calculating probabilities using this distribution.